Good evening, sir.
Yes. Yes. Good afternoon. Yeah. Please go ahead
Yes.
with your question. You can introduce yourself.
Yes. Good afternoon, sir.
Good
Uh,
afternoon.
my name is Srikanth, sir. I am PhD first year student in IIIT DM Karnool. Currently pursuing PhD. Recently joined, sir, January. So my research area is digitalization in manufacturing, sir. So in that my research area, some robotic parts are robotic also involved. So for that robotic, need some knowledge on control system. How can I control my robots in industrial point of view? So in that perspective, I take in this course, sir.
Okay.
So basically, I am mechanical background, sir. I directly pursuing direct PhD after BTech itself.
Okay.
So I completed my BTech in mechanical engineering and doing PhD in mechanical engineering too. So I am facing little bit difficulty with regarding this course, sir. So,
so what are the specific like points which you are finding difficult? You can ask.
Regarding this, till first week I solved the inverse Laplace transformation and the transfer function, sir. But when it comes to Bode plot, no, that part I'm confusing, sir. So can you suggest some any book so that I can gain background knowledge before attending lecturer or some
Bode
sort
plot?
of? Yes, sir.
So see, Bode plot was being taught from the book Norman Nice. I have the book with me. This is the book. This is a standard book. Okay, Norman Nice Control Systems Engineering. Okay, you can actually go ahead and check that book, and then there is another book by Nagraj Gopal.
Okay.
This is that book. Okay, so these two books are, I think, good enough for understanding whatever questions that you are asking. But if I may ask, what is the specific like? Where is the problem that you are exactly facing? So, are you able to understand what the plot is?
No, sir. No, I'm not understanding that plot and what plot that makes sense. And how can I utilize in my field those concepts? I'm not understanding. Laplace function. First week I understood very clearly, sir. From second week and third week onwards, I'm facing little difficult, sir. This time domain analysis. So for understanding this time domain analysis, open loop, closed loop, and a background knowledge I need to acquire like regarding signals and systems, sir, or no?
No. I think, see, if you know differential equations, I don't think you will need anything from signals and systems. If you look at what I have been teaching, I have never used signals and systems analysis much. It is mostly Laplace transform and differential equation. And for that, I have given you the prerequisite in the first week. However, of course, since these are like within a particular time frame, I have to teach, so things might be moving fast. So let me just maybe I'll just briefly explain you what Bode plot is once, because anyways no one is here. I mean, I think one more kind of person is there. We'll get to his question also. So see, Bode plot is, so do you understand what transfer functions are now by now? Do you know what transfer functions are?
Yes, sir. Transfer function, the output by input.
Exactly, in Laplace domain. Correct?
Yes, sir.
So now what you can do is you can replace the S variable there with j omega, right? So if I can share my screen, let me just share my screen. Yeah. Is my screen visible to you all?
Yes, sir. Visible.
Okay. So here, see, if you look at, so suppose this is the transfer function of the system. So this you have understood, I guess, right? What is the transfer function? You have already told you have understood. This is the output by input. Now what I can do is in place of Js, I can put j omega, right? This is a complex number that I can always put. Omega value I don't know, suppose. Okay. So now once I put that, the expression will become something like this. Let us forget about this part for now. Okay. Just think about this expression. If I take this expression, I can write this. So the numerator here will be some polynomial in omega. Do you agree? Because if I multiply it out, I will get something in omega, and then z1, z2, all these terms will also be there, but they are constants, right? But omega is something that is not a constant. I can change that. Similarly, in the denominator also, you will get something like that only. Correct? Again, it is a function of omega. So I can maybe write in this way that top part will be a function of omega and the bottom part will be also a function of omega. Okay, it varies with omega. As you change omega, you will get different complex numbers at the top and bottom. So that means as a whole, suppose I give you some complex number omega equal to 10. You can plug in the value of 10 and then you will get some complex number, say a plus jb at the numerator, and at the denominator you will get suppose c plus jb. Up to this, is it clear?
Yes, sir. Clear, sir.
Okay. Now once you have done this, you can rewrite this in magnitude. Let me not write m, maybe let me use something like say t. T is the suppose magnitude. What is magnitude here? Magnitude is root over of a square plus b square by root over of c square plus d square. So this is the magnitude, right? And the same way you can also find out the phase. The phase will be tan inverse of b by a minus tan inverse of d by c. Correct? So since this is a complex number, I can always write it down in the polar form where we'll have a magnitude and we'll have a phase. Up to this, is it okay?
Yes, sir. Okay, sir.
Yeah. So once I get that, so basically then the magnitude that you got will also be a function of time, a function of omega, because omega I can put different values. So you will get some magnitude t, which is a function of omega, and some phase, say phi, which is also a function of omega. So as I change the value of omega, the magnitude will change. As I change the value of omega, the phase will also change. Now, so now I can form a table, right? You populate with different values of omega. I find different magnitudes and different phase. And then I get a plotting. I will get two plots. One will be magnitude plot, where it will be in the x-axis omega, and in the y-axis I will have magnitude. Whereas for the phase plot, in the x-axis you will have omega, and in the y-axis you will have phase. So this is what in general Bode plot is. Only a little difference is that the magnitude we are not plotting directly. Instead of that, we are doing 20 log of t of omega. Okay, and the phase is in degrees or radians depending on how you want to draw. So I get two plots like that. Up to this, is it clear?
Clear, sir. Up to
this is what Bode plot is. Nothing more than that. Okay, this is what Bode plot is. Now, what I did in the class, like or in the lectures, is basically. See, it is very, if you ask me to draw the Bode plot, of course, I can take a computer, I can write down a code where I will give different values of omega and populate this table of magnitude and phase for different values of omega, and I can plot it with the help of a software. That is doable, of course. However, suppose you want to draw the Bode plot, roughly, approximately what the Bode plot would be. Why is it required? Because sometimes you might not have access to all these computers. Maybe suppose you are taking some data from something and you want to draw in over different frequencies, how will the system behave, what will be the magnitude and what will be the phase. So for that, these methods, the method that has been explained in the lecture, for that those methods is in there. That is an approximate Bode plot. That is not the actual Bode plot. The actual Bode plot is just now whatever I have just now told you, that as you vary the value of omega, 20 log of magnitude and phase. These are the two plots. This is the Bode plot. Now, up to this, the basic idea is clear. Now, the algorithm by which you draw the approximate Bode plot is given in the lecture. Okay, you go slowly. Do not hurry. If you have questions, we will take it up. I mean, of course, it might take some time for you to understand. It's fine. Okay, you can easily text write in the group and or get to us. You have our contacts, so you get to us, and I can specifically explain you slowly also. It's fine. Now, question that you asked was, what is it the use for this, right? In your PhD, it might be useful. I don't know, but like, see, everything that you learn might not be useful in the work that you are doing, but it might turn out sometimes you might need it. Generally, this is very useful. Why? Because suppose you do not know the transfer function of a system. Okay. With the help of just the input data and the output data. What is input data here? Sinusoidal signal. You can see this sinusoidal signal that we have. The sinusoidal signal here is the input. So you can give sine signals with different frequencies, sine t, sine 2t, sine 10t, and then at the output check what we have. I think we had already shown a video in which we are doing this. You are finding out the magnitude and the phase, right? In the lecture we have shown that. So once you have that data, experimental data, this you don't have any idea about the transfer function of the system now. Okay. Once you have that experimental data, with that data, you can actually go ahead and estimate the transfer function also. Not always, but in many cases you can. Okay. And the example that we showed in the lecture was one such case where we had found out the transfer function of the system using the experimental data. So in your case, where whatever thing you are working on, chances are if you are working on some robotic things, so there might be motors there. If you want to model the motors, if you want to find out how what is the transfer function of the motors, maybe you can use this idea and find out the transfer function of the motor. So in this case, you do not even have to know about what is the resistance inside, what is the inductance inside the motor, all those nitty-gritties. Even if you do not know, even then you can get an estimated transfer function. That will of course not be the actual transfer function, but that will be the estimated transfer function of the system. So the idea is that Bode plot has, of course, Bode plot has other advantages also, other things also that it can be used for, which is in frequency in domain. But in this course, I have not talked about frequency domain much. So I'll Bode plot in general in this course, what I have said is that, okay, you can use it for finding out transfer function. But that is not the only use. There are a lot of other uses of Bode plot. For example, it can be used for controller design also. Okay, that we are not covering in this course. But at least basically what I wanted to give to whoever is listening to this course is that you can use this idea to get the transfer function of the system, even if you do not have much knowledge about the system. Of course, you have to check, you have to cross-check whatever transfer function you are estimating, is it correct or not? All those things you have to do, but in general, you can use this type of methods. Okay, could I give you some brief? Of course, I could not get into the algorithm of finding out the Bode plot, but do you understand what exactly Bode plot is now?
Yes, sir. I got it. It representing a transfer function replacing j omega, and we are finding magnitude and phase of that function. Correct. That is just the plot. Okay. Now, approximate plot, the algorithm that I have shown, you have to go through it. It is once you understand it, it will be. You have to just go through some problems. I think. Okay. Take some problems up. That book that I have referred to, that Norman Nice and Gopal's book, lot of problems are there. You can go. There is another book actually. Can you show that? I will note it, sir, because I am referring right now Signals and Systems second edition, like Simon Heikin, Barry Van Wyn. Oh, that is Signals and Systems. That is not Control Systems book. That is a Signals and Systems. This is the book. Okay. Sir, Control Systems. Wait a minute. Is it the opposite? Right, sir. Right. I'm taking photos, sir, to my mobile. Yes. Took, sir. Taken, sir. Yeah, this book took 1 minute. I'll give you the references. Good that I have the books nearby only. This is another book. Done, sir. Okay. And I have this book also. This also has a lot of problems. Like as part of in view of this course, which is your referring content from which book, sir? First book. I am mainly using the first two books that I have shown. Okay. The third book, that B.S. Monkey's book, there this has a lot of problems. If you want, you can practice from there also.
because control system is something like you have to practice a bit. Once you get used to it, it becomes you will understand it much better. So you can take problems from there, and you can practice.
Okay, sir.
Is that fine?
Yes, sir. Yes, sir. So,
Any more questions you have?
To register for exam for this, sir?
Yes, yes.
How many students are registered for this course exam?
Oh, how many students are registered? I have to check. Check how many students are registered. Okay, I'll tell you. I'll ask my student to check. But I have not checked for a long time how many have registered actually.
Yeah. It's a new course, sir. Is offering first year, na? So when I registering the PhD, I gone through the robotic course and I find the advanced robotic and control engineering course. These two courses I find out towards my research. So I registered these two courses.
Advanced control you are doing? Advanced control from?
Advanced robotics from IIT Kanpur, Ashish Datta, Professor Ashish Datta, mechanical engineering robot department.
Okay, I think. Do you have any more questions? I'll go to the other person. There is another person if he has a question. Otherwise, I'll come back to you. We can talk after.
Yes. Please listen his query. I will. Until that time, I will prepare my questions. If anything.
Okay, sure. Yes. Akash, do you have any questions? You are not audible, it seems. Akash, you are not audible. One thing, if you are not audible, you can even write your query. Can check that. Or check your microphone maybe. Once. 2162 has been enrolled. Yes, Akash, yes. I can't hear again. Yeah, you were not audible, it seems. In between, I got your sound, but now I can't hear you. Okay, until Akash figures out his. Are you there? Okay. Till Akash figures out his microphone issue, let me go to a question that was asked in like the form that was floated. Okay, so so one of the questions was regarding this was regarding how can we realize electrical circuits from transfer function or system equation, because the system model can be same for many systems. Okay, this was a question that was asked. Now, see, so basically, what I could understand from the question is that if you know the differential equations of a system, how do you find out the electrical equivalent of the system? If I'm not wrong, that is what is being asked. Okay. See, in the course, I have not gone into the idea of something called analogy. Analogy of systems basically. So basically, once you have the differential equations, you can go ahead and make a mechanical system out of it, or you can make a electrical system out of it, irrespective of where the differential equation is coming from. Okay, I skip that part. So see, control system is anyways vast. So as I had initially said, that this course has lot of things like it has advanced control also. So I had to leave certain things out. But I'll just give a brief idea as to what that is, so that if you are interested, you can go through any book like the Norman Nice book that I have just now showed, or the Nagaraj Gopal's book. You can refer to that. So let me just share my screen. Okay. So see, if you have a series RLC circuit, okay, for a series RLC circuit, you can always write down the KVL equation in this form. So here basically V of t is equal to IR plus L di dt plus 1 by C integration of I dt. Okay, and this if taken to the Laplace domain becomes this, which you guys right now of course know that, because I will become suppose is being the Laplace transform of I, then di dt becomes s of I, 1 by C integration I dt becomes is by sc. Now this becomes your Laplace domain equation, the differential equation written in Laplace domain form. The same thing when you look it from for a mass spring damper system, which is a mechanical system, you can get a force equation of this form. So basically it will be, you'll have to write down a free body, you will have to draw a free body diagram for this mass. So if force is being applied in this direction, of course there will be reaction force in this direction, and this is the displacement of the mass. So the reaction force will be mx double dot, okay, ma, and then this is the spring. So the spring constant being k here. So the reaction force for that will be k into x, and for b it will be b x dot, b being the dashpot or a damper. Okay, so in this case the equation, the differential equation will come out to be ft equal to kx plus mx double dot plus bx dot. Okay, and this equation again when written in Laplace form becomes this. Okay, and from here to just make it similar looking with this, I can take out s from here and the same equation can be written in this form. Okay, now notice one thing, and this is for rotational system. Let me not write down the equation for rotational system. This is the Laplace equation that you will get, and you can rewrite the equation in this form again. Let me just try to explain with the mechanical and the electrical system. So you can see that once you look at the equation, this equation looks almost similar, right? Here you see B is acting like R. Here M mass is acting like inductor. Here 1 by C here is acting like K. Okay, here current is acting like S of X, means X dot, X being displacement, and S of X means ddt of X, which is velocity. So current here is working, is like analogous to velocity. Voltage is analogous to force. So once you have the force equations, you can actually replace these variables with its electrical equivalent. Say force can be replaced by voltage. Similarly, mass can be replaced by inductor. So in this way, we can actually write down the same equation in an electrical form and then draw the electrical circuit for that. Okay, an example can be, let me take a quick example. Okay, the same thing can be done. This I did. This is what is called force voltage analogy. Why? Because force is being written as voltage. Okay, because force in mass spring damper is being written as voltage. Same thing can be done for in the force current analogy also. The RLC circuit in parallel equation will be of this form. Here force will be analogous to current. So this is force current analogy. So if you take a simple system like this, again, see, this I'm just explaining for like the question that has been asked. Okay, you can always go to a book and get more details about it. I'm explaining this briefly. This I have not covered in the course. Okay, so I'm just explaining because the question was asked. So once you have this, suppose this is a spring mass damper system, you can go ahead and write down the free body diagram. From the free body diagram of this part, you can write down a differential equation. Okay, what will be the differential equation, right? Here is a force on this direction. So there will be a reaction force of this mass, M1 x1 double dot. Then K1 will also try to resist that movement. So there will be a force in this direction. Then there will be a force in this direction due to this spring, but this one will have a relative displacement because both these points moving. This point is moving at a displacement of x2. Similarly for B3 and B1. So at the end, you can come up with a differential equation of this form. Similarly for mass 2, if you go ahead and write down a differential equation, you can write down a differential equation of this form. Once you have that, then what you can do is, see, each term here you can rewrite this. This term you can rewrite in this form. Why am I writing in this form? See, S of x1 was displacement, and displacement we have thought of it as voltage. Displacement displacement we have thought of it as voltage in force current analogy. So this becomes like voltage divided by resistor. Okay, this becomes like voltage divided by resistor. So you can not resistor, in this case it is 1 by SC. So this is capacitor. So using this equation, you can finally, using these two equations, you can go ahead and draw electrical equivalent where this becomes one voltage node and x2, S of x2 becomes one voltage node here. Okay, and you can draw this. Since this session is getting recorded, this entire slides are getting recorded, so you can go back and look at this. Okay, if you have questions, of course, post it. But this analogy thing I have not taught in this course. Okay, given and this was not part of the syllabus as well. So given the time duration that we have, it's not possible for me to go to everything like this. But the idea I am giving you, the idea is that you have to find out the analogy. Okay, if there is force, am I writing force as current or am I writing force as voltage? Once you fix that, then you have to write down either the KVL equations or the KCL equations and then try to draw the circuit. Okay. Anyways, briefly I explained whatever the question was. I tried to explain. I hope that was the question. If not, please write back to in the Q&A. I'll try to get back to you. Akash, is your microphone fine now? Let's try. Has he written on the chat box anything? Akash is typing something. Yeah, it's fine, Akash. So sometimes it happens. I mean, when you need mics more, I mean, it sometimes doesn't work. Please go ahead and write down if you have a query.
Is it audible?
Yes, it is audible. Yes, great. You are back. Okay. Yes, go ahead.
Sir, I don't have actually problem like theoretical problem anyway, because I understand what you're teaching. I'm enjoying rather. But the problem comes when I have to realize the same system into or analyzing the system when I want to analyze. For example, I have 4 DOF robot. So if I require to analyze what kind of if I want to make it smooth in sense, right? The driver train should in a way it should be smoothed, right? Then how should I realize that system so that I can use control system methods to make it happen, whatever, in the way.
Just if I am not wrong, what you are saying is that you have a robot which is what, four link robot?
Yeah.
What is it?
4 DOF.
4 DOF. Okay, 4 DOF robot you have, and you want to make it better, like the performance you want to make better, and how can you use the control things that will. Okay, see, we will talk about 6 DOF quadrotors at the end of this course. However, I mean, you have to understand that when this is an introductory course, right? An introductory course will have only simplified models, okay, where, for example, we took the DC motor case, okay, or the simplified model of the quadrotor, and then we are trying to explain all the concepts. The question that you are asking, for that, I personally feel that you have to first write down the different the system model. Do you have the model of your system? Do you have any differential equations or anything like that?
Sir, currently I have not. So yeah.
But 4 DOF, see, this is a very standard thing, huh? 4 DOF. So 4 DOF differential equations are generally already available. You can directly look up and check that. Okay. So once you have the equations, okay, then you will have to go for the controllers that you want to use. How many input? So 4 DOF, you have what? 1 input, 2 input.
Sir, actually it's 2. One is for rotatory, one is for revolutionary.
So do you have 2 input? As soon as it becomes 2 input, PID methods, at least directly like this, whatever we are doing, it won't be helpful directly. Okay. If you have more than 2 inputs, then you will have to use multiple loops to control the system. Okay, it might be it will be like one PID that will take care of one thing, and then there will be another outer loop where there will be another PID which will take care of another thing. Okay, so generally that is how it works. But there is again the state space part, which is the modern control part, where you use the 2-input case. So what I will do is I will let me check if I can do something about it. 4 you have, right?
Yes.
What exactly is your system? Let me
Z-axis is rotationary, like rotation, and then the above XY axis it would be revolutory. The link one is rotatory around Z-axis. I hope you know.
Can you okay? Do one thing. You can post your you have the system, right? You can post the video or the picture of the thing in Q&A. Can you do that? Not now. I mean, because if I see the system, maybe it will be more helpful for me actually. What type of system are you working
on? Sir, can I do like 2D diagram for it right now? If
yes, you want to share something, you can share. I'm not sharing anything. Do you have share access? Can you check?
Yes, I have.
Yes. Please then share.
Sir, wait a second. Let me.
Yes.
Move it. Have to choose anyone. Actually, let's draw. Got it. Yeah. One is.
I see line. I see elbow, or chandelier, or shoe, or springboard. I see hat, or yoga, or sailboat.
Damn, it's bad. Anything. Yeah. So the platform is this. This is platform. And this and this. So we have this rotation, and another way is rotation and this. So
so this is a one link arm or what?
Yeah, but this one is like one is motor right here.
So this is like one link is so one link.
Sir, one and
two at the like bottom there is one. So bottom one.
This one is link 1 and this one is link 2. I think there is yeah.
I think something like that we might take up in the robotic arm week. Yeah, I also feel how can it be 4D? Platform is moving or what?
No, platform is not moving.
How come this is 4D?
Sir, I'm actually, I think, using like robot arm as well, like end effector I'm adding maybe. It can be.
Oh, there is an end effector also?
Yes.
One. So you have one. So you have one link, like two joints, one at the bottom, and then there is one more joint, and then you have an end effector. That is the arm, right?
Yes.
Yeah, 3D. Anyways, so I think we will take up something similar kind of thing in the week 11, I guess. Okay.
Okay.
Let's see. I mean, so what you are asking, there is no like straightforward answer to that. Oh, you do this, your work will be done. Okay, that's not how it works. Okay, so we'll have, let's see, because in robotic arm part, we will be anyways talking about these links. And there, hopefully, your question will get answered. So right now, what are you? Do you have is it's open loop or is it closed loop? You have a controller already in place?
Sir, currently, actually, I'm kind of building it. So it's
oh, okay. You are building from scratch.
Right.
Then see, so right now, so what you can try is you can try like for each motor, you make your own. Okay, by the way, what are the motors? Is it DC motor or servo motors?
Sir, it's DC.
DC motor.
Yes.
So for each motor, then you will have to have speed control and position control, right? Yeah. So anyway, speed control and position control is being taught in the course. I mean, that at least for each motor, you can have your own controller. But of course, for a robotic arm, if you have to particularly go to a position, then things are linked. It's not like straightforward. But at least for those motors, you can have your own controller. So if you try to control the angle at which the link will rotate or the speed at which the link will rotate, that you can do with the help of PID directly. I mean, simple 1-1 PID corresponding to each block. So, I mean, yeah, I think that might help, but for the entire system, you'll have to go into the dynamics.
Sir, actually, actually, the thing is, I have seen one video where it was used for like measurement. It was a like arm as well. So I have seen it. It was so smooth, like really very smooth robotic arm. So I thought like something can be built. So how can I build it? That was the idea, like inspiration.
No, it can be done. It can be done. The only thing is that you will have to understand the dynamics of the system. Okay, let's see. I'll try to put up something possible. Some material maybe I will post. So you are in that group, right? In that Q&A group.
Yes.
Yeah, I'll try to post something. Of course, we are going to take up robotic arm anyways in week 11. So let's see if possible. I'll post something earlier or put something in week 11 itself. And specifically for your case, if I can give you some inputs, I'll try to give that. Is that fine?
Yeah, sure. Yeah, actually, I've also started like following the book, The Norman and I. It is so good book. Like I have 6th edition, and it is really nice. So
it's a very nice read. It's a nice read. You can just lay down and read it. It's very good actually.
Yeah. So it has like all the examples, and I'm enjoying it, that part.
Yes,
like
yes.
Because the problem I'm having, like I can understand theory, but from theory to practical to actually use those knowledge into the practical environment, which is kind of always is stuck at some point.
Yeah. So the idea of the course is to give you the basic idea, the first point as to where you can start. But at the end of the day, anything practical you do, you have to get your hands dirty. You have to do it on your own, and you will face a lot of issues. It's not like straightforward. I say something that will work. For you, some other problem might come up depending on your system. So at least one thing that you can do is that if you have the arm, you can maybe interface it. If you have MATLAB, you can interface with MATLAB. If not, even then also you can write down your code. Maybe try to write down a small code where you are trying to control the speed of a motor. That is generally speed control and position control of a DC motor is the first step of getting into hardware. Like theoretically, everything is fine, but if you have to actually do something hands-on, first hello world program I feel for control system people are this speed control and position control.
Okay.
PID, this is making PIDs maybe on Arduino or something else. Anyways, we're going to talk about that. Okay, I think week 6 we'll have that. Now week 5 is already live. So week 6 we'll have one lecture completely on this. Basically explaining how it is. Week 6 or 7. I mean, out of these 2 weeks, one of those weeks we'll have. Okay, And then maybe you can try like whatever we show, you can try to replicate that and tell us if you face any issues. We'll try to help you out. That is the first step of designing a controller, and then for your case, we'll have to look into specific.
Yeah. Okay.
Okay. Yes, any other questions? So I don't think there are only 2 persons. Okay, one more question came up on the form. Okay, so that was a general question. Let me just take the question. Okay, so the question was, so this is a person who assembles and integrates drone components. So his question is, the most difficult process to learn about in this process of assembling has been PID tuning. Please suggest resources to learn PID tuning a quadrotor successfully without fast low oscillations, sluggishness, and hot motors. I have made a 5-inch propeller size racing drone on INAV farmer. I am stuck on default tunes, flying it, not knowing. Okay. See, for quadrotors, we will show one video again in the next lecture. But so at least that will help you understand. But that will help you understand what P part does, what I part does, and what D part does. Okay, the meaning of each of these part, and you will get the intuition as to when to use what. Okay. Now for quadrotors, the things are not that straightforward. Although I have taken simplified model of the system, which is just the drone flying on the z-axis, that is never true. It's not like that. It will always fly in entire 3D world. So in quadrotors, there is always more than one PID. It is not just one PID that will control the entire thing. So there is almost 6 PIDs and sometimes 12 PIDs also. So which means that you have to tune each of them. Now, depending on what type of quadrotor architecture you are following, so that many number of PIDs you have to tune. Okay. Now there is no particular way, at least there is no particular algorithm by which you can tune directly. Okay. But there are intuitional ways by which you can do that. We will try to give you some resources, but with the disclaimer that whatever will be written in the resources, it's not guaranteed that it is going to work for your system. You have to first understand what the architecture of your system is. What is the controller architecture? By that I mean the controller architecture. Once you know the controller architecture as to how many PIDs are there, where are the loops, then you have to go for controller tuning. Okay, so maybe if possible, whoever has posted the post, I can't see the name right now, but anyways, whoever has posted the question, it's more generic question. We are going to show some kind of PID work for drones in the last week, and a simple architecture for quadrotors in the last week of this course. But before that, if you need something, maybe you can post the architecture that you are following. Although you have written that INAV firmware, but I would like to know what is the control architecture. Okay, if possible, try to dig it out. How many loops are there? How many PIDs are there? If you have a block diagram for that, maybe then we can think about it. But the basic idea of every PID is simple. Okay, I is for decreasing steady state error. D is for taking care of transient oscillations. So if you have more oscillations, you have to use D to get rid of the oscillations. All this I have discussed in week 5 lecture. So you can go ahead and look at week 5 lectures, mainly the last lecture of week 5, introduction to PID controllers. And in the next week's lectures also, more about PIDs will come in. Okay, I hope that might help you or help you to understand what PIDs are and what are the role of each of them, P, I, and D in a control loop. And then maybe intuitionally you will be able to tune it. Okay, but I request that you share the control architecture if possible, so that I also get to know what architecture you are working on. And I can specifically answer if possible, because there are a lot of architecture nowadays. UAVs are now standardized as such. So yeah, you can post to that. Yeah, that was the second question that was asked, and I think these are the only two questions that I got on the form. Rest, Srikant and Akash have also asked certain things. There is one more thing maybe I want to address. One was the this was about the phase plot. Okay, there was a question on phase plot in the Q&A. I already, although I have answered it, I would just like to go back to that one. So do not get confused about. Let me just share the screen. So if you remember in the Bode plot, we had these factors, and corresponding to each factors, you had these magnitude and phase plots. Now, I had given a question which was this. This was the question that I had showed in the lecture. And for this question, we had found out the factors, and then we wrote down the entire table for the magnitude part. Now for the phase part, there was a question. Okay. Now for the phase part, you have to be careful. Okay, how to do the phase part. First of all, for 6 by j omega, see, first thing, all the things written in this part of the table are slopes, not phase. Okay, remember these are slopes. Okay, this is very important. Now, once these are slopes, then you will understand for 6 by j omega, if you remember, 6 by j omega is will give you, this was a constant. So there is no, for constant, there is no slope. Okay. And even for 1 by j omega, there is no slope. Slope is 0. There is no slope change. Only thing is that for 1 by j omega, it starts at minus 90 degree. And that is what is being written in the table. See, 6 by j omega, for the 6 part, there is nothing. 0 degree phase, and the phase, there is no slope as well. So 6 is anyways out of the question. 1 by j omega, also there is no slope. Okay, so there is no slope change. Only thing is that it starts at minus 90 degree. That is why you can see that it starts at minus 90 degree. 6 by j omega. So the slope phase plot starts at minus 90 degree, but the slope change is 0 everywhere for this part. For 1 by 1 plus j omega, you have to go to 1 and 1 decade before 1 till 10. So if I go back again, back to 1 by, this was 1 by 1 plus j omega t. So you can see that here, if in this example t was 1, so I have to go to 0.1. From 0.1 to 10, I will have a minus 40 degree per decade line. But from 10, there is no slope change. Okay, so that is the reason you will see that from 0.1, if you go, you see from 0.1 there is a minus 45 degree slope change starting. It started. Okay, and then the slope change has ended at 10. Just before 10 also it is minus 45 degree per decade line. Okay, just from 10 there will be no contribution. That is why I have written 0 here. Do not think that is the value of the phase. So at this point, from this point there will be no phase. There will be no phase change. That is what is being written here. And I think someone got confused with that and I had wrote a question. So similarly for 1 plus j omega by 4 also, you see I go to 4, go back by 1 decade. So from 0.4 it started and till 39.999 it will be plus 45 degree. At 40 it is 0 because there is no slope contribution. There will be no slope change from that point. Similarly for this one, it was the corner frequency was 6. So from 6 to again 59.999 it is minus 90 degree, but at 60 there is no slope change. Now you add all these things up. These are the slope changes that you will have. Again, you are starting at minus 90 degree. So you'll start the diagram at minus 90 degree and then you will have to go, okay, till 0.1 there is no slope change. From 0.1 there is minus 45 degree per decade slope. This way you have to keep on going ahead. I hope the table is clear. Even still now, even if it is not clear, please let me know. Okay, I mean it's not that it will be clear with one example itself. please let me know. If you want to read a book, again, Norman Nice, chapter number I don't remember, but it has the entire idea. How to draw the approximate body plot, how to draw the approximate face plot. Norman Nice's book have it. Okay, you can go ahead and look at that and read that part to understand what needs to be done. Even still, if you do not understand, you are most welcome to ask. Please ask your questions in the Q&A. I'll be very happy to answer those questions. Okay. Yes. Basically, these were the things. I mean, these are the, I think in Q&A, this was one of the questions that I had already answered, but I felt that it should be answered better way. So that's why I'm just explaining over the video. Okay. So all of you can have a look at it. Yeah. Are there any more questions?
Sir, is there any group for this course? I don't have that Q&A.
Yes, Vikas, go ahead. We can talk now. Yeah. What were you saying?
For this course, any group you created for posting that question separately beyond the live session? I don't access those groups actually.
I don't understand. Can you again repeat? I didn't hear
for
what
this
you
course,
said.
You created any separate group for posting question after?
No, it is in that Q&A is there, no? You post the link once. So there is a Q&A part where you can ask questions. Okay. My TA is going to Paroj is going to upload the link. That is already there in the course. It is there in the course page, right? It should be there in the course page.
Feedback form. You are saying feedback form.
No, not the feedback form. I think. Not the feedback.
Sir, actually, it is available on NPTEL website.
It is in the NPTEL website. Okay.
Yes.
I have not checked it. Just a minute.
Can
you check the NPTEL website? It is there. Can you
SWIAM as well?
The SWIAM is there.
And sir, I kindly request if you have time for the live session, can you take every week completion of after week by week? You are taking after
week by week.
This live sessions clarifying doubts. At least it's just
I will have to check. Fine, I understand your query. I will have to check about that with the administration. Okay, so I what is the rules and all. I'll just talk to them. If possible, I'm open to that. I'll just talk to them and let you know. Okay, but again, first I'll show you the Q&A thing, because if you do not know the Q&A, you won't be able to give me questions. Have you put it up? Akash has put it up. Yeah, I think Akash has put it up in the group. Can you see that, Shrikant, in the group?
I hope. Okay. I'm joining, sir.
Yeah, please join that. So you can ask your questions there. You are most welcome to ask questions. And about what you are asking, let me see. Let me just talk out with our NPTEL team here, and let me see what can be done.
Most of the NPTEL course, at least a research scholar able to take under working with you, that have facilities, sir. I have took most of NPTEL course. At least research scholar will take those doubt clarifying session.
Yeah, this is my first NPTEL course. Okay, so certain things I'll have to figure out. I'm sure, since I got the feedback, okay, I'll try to figure it out. Okay, rest assured, something I'll work out so that you always get the feedback. If you have questions, you can directly ask also. We'll work out something. Okay. So what you can actually put your can you put your email ID on the chat box?
Email ID also.
Akash, yes, Akash as well. You can put, so it will be easier for me. I will just take those email IDs out, so that if I have to reach out in case, I can reach out. Akash and Srikant, both of you can do that. Yes. You take it up.
I dropped, sir. Can you please check?
Yes. We have noted it down. We have noted it down. Yeah, if required, I'll try to directly catch up with you guys. Okay.
This is a basic course towards NPTEL, towards a control system, sir. Advanced topic you are also covering.
This is not advanced. This is basic. This is more or less like basic control system, and then modern controls basic. Okay. Too much advanced. This is not too much advanced. It is not even total. It is not even drone or robotic arms or anything like that. It is basic control system. However, application wise, drones and robotics arm we are focusing. But that doesn't mean that you will know everything about drones and everything about robotic arm in this course. This is the introductory course.
Okay. Okay, sir. And one thing I have doubt, sir. In week 2, the 10th question, you are giving one data set in MATLAB file. So for solving such question, I faced problems, sir, because I need to extract those.
So for those questions, so you can actually directly follow the. Could you see the code? That you could see the code in the lecture, right?
Sir, see.
In the video, the code was shown. What is the code we have used? You try to directly use it. There is no like the code is similar. I will just maybe share this one is week 2. I will just show it on the screen. This video is getting recorded, I guess. So you can check it. So this is week 2 score. Okay, this is week 2 score. So you can go ahead and try to figure out what are these. See, you will face some issues. This is the first time maybe you are writing these type of codes. Don't worry about it. Okay, you'll get used to it. For now, if you are not understanding how to write the first line of code, you use whatever I have just now shown. Okay, use this and try to write down the code and try to understand what the code is, each line of the code. Once you get used to it, then you can write your own code also. So this is week 2 assignments code. Okay, and this is exactly the code that is shown in the lecture also. Okay. So you write, fine, you will face issues, don't worry. You can post your errors in the group. Now that you know where to post, some of them are already asking questions like that. We will help you out, okay? In any course, new course, it is a bit of a, like you take some time to learn, right? At the beginning, there is a learning curve. Once you get used to it, you will be fine. Okay. So you just post your queries. You have the group link now, which Akash has posted. So you can use that, and please put any queries. Don't worry, silly. Don't think that, oh, this is a silly question. Don't think like that. Any queries, anything you are not understanding, you just put it up. Fine.
Okay, sir.
Okay, I think time is up or what?
Sir, I have one question.
Yes.
Actually, sir, I was pretty busy last week, and I didn't able to actually like put out the assignment of assignment 3, and even 2. So can you extend the date for it?
Oh, that dates are fixed by NPTEL people. I mean, that is like a hard deadline. Anyways, lot of time is given for those. So what is the last date? He's asking about 3, I guess.
11.
Week 3, last date is. The questions are straightforward. Try to quickly do it. Don't take much time. 15-20 minutes it will take, I guess. Okay. Try to. I mean, if you're facing issues, that's ask in the group.
No, sir. It wasn't the issue. Actually, it was kind of busy. So busy week. So I wasn't able to.
Yeah, but I mean, unfortunately, so these are hard deadlines from our side. Okay. Week 3 is when? It was 11th of. Yeah, 11th of Feb. Anyways, you can take up the other assignments after this. Okay, so because these are hard deadlines, we cannot change it. We give a lot of time to finish the assignments, and that is some policy that we cannot change it. So it's not even in my hands now. You finish it. It's fine. This time you could not.
Actually, sir, I have solved it, but it was like 11, 59, and 12, and I clicked, but it didn't go.
Then you have to do faster, I guess. Huh? You have to work in a one day before, I guess. Okay.
Sometimes server will busy, so that's why they won't accept.
So then don't wait till the last moment. You have a lot of time to finish. I understand this mentality of doing things at the last time. I was also a student sometime, but yeah, you have to do it. I mean, that's it. Okay. Hopefully next assignment will be on time.
Yes.
Okay, I think our time is up. If you have no questions, then I think we can log out, I guess, right?
One last question, sir. This
yes,
assignment to solution not uploaded, sir. Can you?
It will be uploaded. It will get uploaded. We are taking care of that.
Sir, when are we going to have this thing, like on Meet?
Week what?
When are we going to have this Meet again? Is it scheduled in your timeline?
The next date has not been yet fixed, but in general it is like monthly once. But there is a suggestion of more. Then let's see. I'll post it. Okay, I'll post it in the group. Fine. So
at least from research scholar working under you, at least make ready to take at least one session after completion of 1 week. Like.
Oh, that's okay. No, that's what I'm saying. I'll figure out something. Let me just discuss once, and I'll figure out something. Just keep an eye on the posts. I will post it up in the group itself. Okay. Okay. Then yeah. Thank you. Thank you very much for your questions.
Thank you,
yeah. Hope you are enjoying the course. Yeah. Thank you.
Should we leave, sir?
Yes. Yes. You can. हाँ अभी बंद कर सकते हैं क्या? ठीक है ये लाइव रिकॉर्डिंग जाए मतलब रहेगा राइट? यूट्यूब में रहेगा ठीक है ओके थैंक यू